Hello everybody. Today I am going to demonstrate how to use HSPEXP+ for hydrology calibration for an HSPF model. We have a simple UCI file here where the time series output is written to a WDM file and it has very few operations. It runs for 3-year period. I'll also just quickly check the WDM file. WDM file has multiple time series, but for our purposes of hydrology calibration, we have added observed flow time series. These are the time series where the scenario is observed and the constituent is flow. Those are the time series that you can use for hydrology calibration. We'll quickly check the ID number of these time series. So adding attributes, ID. So 261 is the ID. I have already seen the model, so I know the location Upper Marlborough with the dataset number 261 is where we want to calibrate this model to. So we'll close the WDM file and open the UCI file in WinHSPF3.1. WinHSPF 3.1 is available with BASINS 4.5. BASINS 4.5 right now is under review by EPA, and as soon as the review is finished, BASINS 4.5 and subsequently WinHSPF 3.1 will be available for public. Once you open the UCI file in WinHSPF, we go to Output Manager. Output Manager has multiple options. The first option here is hydrology calibration. There is text that describes what this step will do, and I would highly suggest you to read this text. We'll click on Add, and we see two frames. One of them shows all the reach operations, and the other one shows the observed flow time series that are in the WDM file. I want to calibrate reach 5 and with the observed flow data at dataset number 261. The location is reach 5. The base DSN means that all the new time series will start with that base DSN. So if I make it, let's say 5000, so all the time series that will be generated after this process in the WDM file and the UCI file will be numbered 5001, 5002, 5003 and so forth. And that is just for user friendliness. You can have any WDM, any base DSN here. Click on OK, close. As you will see in this folder, an EXS file is produced, but to make sure all the data is populated in the WDM file, also we will run the model. Get the warning that changes have been made. We want to accept the changes and run the model. Since it's a small model, it runs very quickly. Okay, this is done. We can close it, and we'll first quickly see the EXS file that was produced by this process. So EXS file, you will see there are many lines with 3 stars. Those are comments. Expert system does not look at those lines, but I would highly suggest you to look at those text, look at that text to understand what it means. And the description of this EXS file is also, you can look at the HSPEXP+ manual to understand all these lines. The major point is that in this line, these 4 numbers, 261, that is the observed flow data set that we selected, and 5001 is the simulated flow volume at reach 5. The area draining to that reach is 51,931 acres. And the seasons and months are selected by default. You can edit them. Before editing, I would again suggest you to refer to the manual. These storms are selected by some base flow analysis. Again, I would suggest you to look at these storms individually and correct them or change the dates if needed or reduce the storms if needed. Then we'll open HSPEXP+. Right now it's version 2.0 beta 5. By the time this version is released, the proper final version 2.0 will be available. So we quickly browse to the folder where our file is. If I have used that, if I opened that UCI file before, it shows up in the drop down box here. Here it shows. Otherwise you can always go through the normal browsing steps. So I selected the correct UCI file here, click on open. HSPEXP+ looks at the start and end date and fills it here. Sometimes you may select a different analysis period, and we'll discuss that in other videos. Since we have already run HSPF once, we will only check the box for hydrology, calibration, statistics and graphs and click start. So what it's right now doing is that it's done. So what it did was that it did the comparison of observed and simulated flow data and generated a bunch of graphs and statistics, and we'll look at a couple of them quickly. There are a lot of statistics and graphs, and I would suggest you to look at each one of them individually to understand what they mean. Some of the examples here are annual flow statistics. So this shows how much is the rainfall, how much is the observed flow, and how much is the simulated flow, and what is residual. There's expert statistics that tells you, that gives you some more detail on a top 10% flow on and what is the error. In this case we are under simulating. It's a non-calibrated model. This is a flow hydrograph for the entire model simulation period. This is a flow hydrograph for first year, and then this is the flow hydrograph for the same year at log scale. This is a similarly there are graphs for every individual year. This is a flow frequency duration curve. As you can see, we are simulating lower enough, and this is monthly, how well we are doing in every individual month. This is advice, and a copy of UCI file is saved so that you can always go back in time to look at the older UCIs. So all of this was produced in a folder called reports_2018. It's the exact time and date when the model last ran. So after looking at it, you can we'll look at what we can do is quickly change the parameters of the existing UCI file. Here is the existing UCI file. I just go and change LZSN. Since we were simulating very low volume of runoff, I'll just change it quickly to 7. Save it, minimize this. HSPEXP+ is already open. This time we want to run HSPF. So I check that box, run HSPF, and then hydrology calibration, statistics and graphs. Click on start again. So what happens is now HSPEXP+ runs HSPF and does all the calibration statistics. It's complete. As you will see that if you see in the original folder, this new folder is produced with the new time because we ran the model second time. Everything like earlier is produced the same thing. As you can see, since we decrease LZSN, all of these errors have come down, but and a copy of UCI is saved again. So this is all the mechanical aspect of hydrology calibration using HSPEXP+. Reading and understanding the advice file, referring to the BASINS technical note 6, and going to those scientific details are for that you have to refer to the BASINS technical note 6 or other calibration document. But this is the technical mechanical aspect of doing hydrology calibration using HSPEXP+. In other videos, I'll demonstrate how to generate graphs from graph specification files and constituent balance reports. If you like this video and if there's any confusion that you did not understand, please let me know and I'll try to clarify those. Thank you for your time.